Now we'll see how to draw the layout of your transmission gate. Okay. So to draw the layout of the transmission gate, so go to right click, go to open terminal, right click, go to open terminal, type CSH. Next, to source your cadence license, type source /home /install /cshrc. Next, to open Virtuoso tool, type Virtuoso space ampersand. So after this, so open your schematic which you have already drawn. Open the schematic which you have already done. So for that, go to File, Open. So you are drawn in a library called as demo. So transmission gate. Select transmission gate schematic, press OK. So first open this. Open the schematic which you have already drawn. So from this, you can launch the layout. So go to launch. Go to launch. Layout Excel. Click on Layout Excel. So it is new layout window. So configuration is automatic. Press OK. So the name, let it be as transmission gate, but view is layout. Automatically it will come. You press on OK. So when you press OK, you will get this layout window. What would have been minimized, open it. So you will get this layout window. It will be like this 4 quadrants. So you will get like this. Okay. So after this, to get NMOS and PMOS along with its layer, go to connectivity, generate all from source. Connectivity, generate all from source. Input output pins, select all the pins. Pressing Control, select all the pins and press OK. So if you do like this, then you will get this NMOS, PMOS along with the 4 pins, right? So to see the layers of NMOS and PMOS, press Shift F. You can see the layout of layers of NMOS and PMOS. You can also remove this outside box. So better I will remove it. Press delete. I can also remove that. You can a little bit move wherever you want. A little bit more upwards. You can move wherever you want. Move like this. Okay. Now from the schematic you start seeing. So your drain of PMOS is connected to source of NMOS. So do that connection. So to do connection, take here wire, plus W or P. So here in layout, to take the wire or metal, the option is P to start doing the connection. So from what I have done, I am started connecting the source of NMOS to drain of PMOS. So I will connect like this. So it is not exactly connected, but it's okay. I will connect and I will leave. So to take a wire, the option, the shortcut here is P. So you make the connection. If you do double click, the connection will be made. But here you can see it not exactly connected, right? You can see here, it's not exactly connected. There is some variation. So to overcome that variation, what I will do, I will just move my PMOS. If I just move my PMOS, see, it has been exactly connected. Now it has been exactly connected. If I zoom also, you can see that it has been exactly connected. So I have shorted this. I have done this connection. I have done this connection, shorting the drain with source. I've done it. And again, short the source of your PMOS to drain of your NMOS, right? So that connection also required. This connection is also required. So that I will do now. So take P, start from here, go upwards and make connection. As you have done adjustment while doing this connection will be perfect. After doing this connection, you have made the adjustment to make the connection perfect. Automatically this connection will be perfect. So you have done this. Automatically showing this is V out, this is V in, automatically showing here. So now after that you have to, so we'll make this, we'll finalize this connections. Take P metal from this and you place this metal here. Take P metal from this and place this metal here. Okay. So after this, see, when you have shorted your drain with source, that end is connected to what? V in pin. That end is connected to V in pin. So this end should be connected to V in pin. So which is V in pin? You click on the pin, right click, go to properties. You will understand which pin. Pin name is V in. So this pin is V in. So this is your V in pin. Bring that V in pin and place here. Okay. And this pin, you click on the pin, right click, properties, this is your V out pin. So V out pin you have to place here. So as pin is a metal and this is also a metal, connection also made through metal. So both will be connected automatically. So you connected V, you have kept V out pin here and kept V in pin here. So what you have done, you have made this connection. This connection you have made, connected to V in, connected this to V out. Okay. Next is your gate connection. Next is your gate connection. So I will little bit increase the distance. Okay. So next is same thing. What nothing I have done. I just increase the distance. That's it. I've created a little bit space. That's it. Okay. So after this, so the next connection is your gate connection. So this gate is connected to VIN underscore P pin. This gate is connected to VIN underscore P pin. So you can see here the gate is polysilicon. Here, if you extend this, pressing P, and if you extend this, you will get polysilicon. Okay. And here also, the gate is polysilicon, but your V in P. So right click properties on this pin, right click properties. If you do, your V in pin is a metal. This is a metal, so that you have to connect here. But this is a metal, but gate is a polysilicon. So metal and polysilicon cannot be connected directly because they both are of different materials. So to connect that, you should use a wire. So when you have a materials of different kind, or you have metals in the different layers, then you should use a wire. You should use a wire. So to get a wire, go to create wire. Wire definition you have, right? You select wire definition M1 to poly 1 and press hide. Place here. You can place, first I will move this pin. Okay. So how to get a wire? Create wire M1 to poly 1. Wire definition name should be M1 to poly 1 because you're connecting metal 1. M1 means metal 1 to poly 1. You place wire here, and from here you can make a connection, poly connection. From here you can make a poly connection. So first you keep this pin inside this. So this wire will be having always two connections, one connection for metal. So I have, so this inner connection, inner thing you can see here, right? So inner connection is for metal. So in that I have placed a pin. So pin has been connected to that. And the next thing is I have to connect to this poly. Wire should be connected to this poly. For that, take up wire pin P. So I'm getting a metal. So I made a connection from poly. I connected to this wire. Okay. So wire is used to connect a poly to metal. So pin I have kept inside this wire. V in P is a metal, and from this polysilicon I have connected to this wire. So wire will be having always two connections. One is for poly, another one is for metal, because I am using a wire here with name M1 to poly 1. If I use M1 to N well, that wire will be having again two connections. One connection is for metal 1, another connection is for N well. Okay. So next here, the same connection I have to do, right? So first I will take your wire, create wire M1 to poly 1, right? I will place here. Now I will make a connection for your polysilicon. I have made, and another connection is, right. So here this should be, the gate should be connected to V in pin, V in pin. So this I have to connect for pin. So pin I will bring here. I can connect through metal also, or simply I will place inside this wire, blue boundary. Inside this blue boundary, I will simply place it. Okay. So this connection is over. So the last connection is your substrate connection. Last connection is substrate connection. See, here we are following N-well process. Here we are following N-well process. So your PMOS will be in N-well. Your PMOS will be in N-well. So first draw N-well for PMOS. So when you draw N-well for PMOS, go to how to draw N-well for PMOS. Create shape rectangle, N-well drawing. Draw N-well for PMOS like this. Create shape rectangle, N-well drawing. So I have drawn N-well for PMOS. Now PMOS is in N-well. Now your PMOS is in N-well. See, this black background is your P substrate. So in P substrate we can form NMOS, but to form PMOS we should have N-well, right? So that is N-well. So now the substrate for your PMOS is N-well. Okay. So now I should connect this substrate of PMOS to source of PMOS, right? Substrate of PMOS should be connected to source of PMOS. But substrate of PMOS is N-well. The substrate of PMOS is N-well, and source is a metal. This source is a metal. I cannot connect it directly. So because of that, I will use a via again. Create via M1 to N-well. Why I am using M1 to N-well is, the reason for that is substrate of PMOS is N-well, and another connection I have to make to metal 1. That is source. Source is metal 1, right? So because of that, I am using like this. So this via I will place here. Okay. Just it is overlapping. I will just adjust that. Again, it will be having two connections. This via will be having two connections. I will draw a big N-well now. Create shape rectangle N-well. I will draw big N-well. Now, again, this via will be having two connections. One connection to N-well. So when I place here, automatically it will be connected to N-well because I am placing it in N-well only. This background within this boundary is N-well. When I place here, automatically connected to N-well. So another connection is metal. So that connection, metal connection, I will do now. So the metal connection I have done. So now your substrate, the substrate is connected to source of your PMOS. So you can see this is source of your PMOS. It is already connected. Like this, I have connected. So same thing I have to do here also. See this black background, what you can see is nothing but P substrate. P substrate is nothing but substrate of your NMOS. Okay. So the P substrate, I cannot directly connect to the metal because P substrate is a semiconductor and this is a metal. Both are of different kind, right? The substrate I have to connect to the source of NMOS. So source of NMOS is metal and this P substrate is semiconductor. I cannot connect directly. So for that, use a via, create via, create via M1 to P sub. I should use now M1 to P sub, M1 to P substrate. That via I have to use, place here. So when I place here, automatically it's connected to P substrate because this black background itself is P substrate. So when I place here, it is automatically connected to P substrate. Only the left out connection is I have to connect this to metal. So this P substrate, this is P substrate, this have to connect to the source. So that if I have to do, then take a wire, press P and take a wire and connect it. Okay, so everything is completed now. So you can go for DRC check. Now we can go for DRC check. So for that, go to Asura, run DRC, Asura, run DRC. Technology should be GPDK 180. Press OK. So it will ask for save. Press OK, and press OK for this, and press yes. So you should get like this: no DRC errors found. So there is no design rule errors. So next, go for LVS, Asura, run LVS. See, I am library demo. I'm checking LVS of transmission gate, schematic and layout. It will verify schematic and layout. It is showing here. Both will be verified whether both are same or not. Press OK. Again press OK. Press OK. So you should get like this: schematic and layout match. So both schematic and layout both are matching, and all the mismatches are 0. There is 0 short problem, 0 open problem, 0 net mismatch, 0 device mismatch, 0 pin mismatch, 0 parameter mismatch. All should be 0, and you should get schematic and layout match. So this completes your transmission gate layout. Okay, thank you.